Hi friends, welcome to GMAT Points video series. I'm Saili Kale. In this particular video, we'll be taking a look at the third part of graphics interpretation. In this case, we'll take a look at distributions. So there are two basic type of distributions that actually come in GMAT exam. One is a distribution where you have points which are represented by a scatter plot, but essentially they are relationship between two variables. The other one is basically a frequency kind of a distribution where you are shown how often a particular observation is made as such. So we'll consider both types of distributions. Their representations are scatter plot and a frequency diagram or a frequency table, but that is not the main point of it. The underlying database or the underlying data of them are different. So we'll consider each data, what can be inferred from it, what type of questions come from it. We'll consider all of that. So let's start with scatter plots. The idea is that a scatter plot, the point, what does that scatter plot point represent? It is essentially not one data point but two data points. It represents a tuple. If you know or remember from your maths, a tuple is basically a connected set of data points where one data point has two values. That's what a tuple is. So in this case, you have how many points? One, say this is 1, 2, 3, 4, 5, 6, 7, 8 points that are represented. Let's consider what are these 8 points. So the first point, for example, if I drop the x-axis, a perpendicular on the x-axis, this is somewhere between 0 and 2. I think it is somewhere exactly midway. So it will represent the point 1 as such. The value is slightly less than 80. Midway would be 70. This would be around 75 as such. So this is 1 and 75. Consider the second point. This is exactly at 2 and it is above 80. It would be, I think 2 would be around 85. Consider 3 point is exactly at 3 and it is between 90 and 100. I would say 95. So 3 is 95. 4 is exactly at 4 and it is exactly at 100. 5 is at 0.5 and it is somewhere between 100 and 115. So I would say it is slightly lesser than 110. So I'd say this is 108. 6 is slightly lesser than 120. So I'd say it is around 115. 7 point, this is 7 on x-axis. On y-axis it is slightly above 120. So I'd say this is 122. 8 is exactly on 8 and it is midway between 120 and 140, slightly less than 130. So I'd say this is around 128. So essentially what is represented in a scatter plot? Every scatter plot point is a tuple. That is, two values are being shown on the scatter plot. The first value can be found by seeing the perpendicular on the x-axis. The second value can be found by seeing the perpendicular on the y-axis. So for each of these points, you can drop a perpendicular on an x-axis, perpendicular on y-axis, and find where exactly is that point. So you get basically a list of tuples like this. When you're reading scatter plots, when you're trying to make sense of the scatter plot, it might be tempting to actually convert the plot into these kind of tuples and then read based on those tuples that what is the trend observed or what is the information that is contained in these points as such. But the basic idea is that you use the plot itself. So if I consider the plot itself, if I remove all of these parts, etc., if I remove all the lines and etc. that I have drawn, what can I say about the graph itself? If I just take a look at the graphs and not the points at an individual level, I see that if I try to join these points, I see that this is a line that is trending upwards. If I join it, I get a line which is going upwards as such. With each increasing age, I see that the y value is also increasing. What is x value? X value is age in years. Y value is height, average height in centimeter. So as the age is increasing, I see that the height is also increasing. So what does this scatter plot essentially tell us? The scatter plot tells us that the average height increases with age, or rather there is a positive correlation between height and age. As age increases, height also increases. So essentially the idea behind scatter plots is that while the data underlying it is a tuple, you should not look at it as tuples or like individual points of data. You should take a look at overall what does this indicate. And the scatter plot shows the relationship between the x-axis and the y-axis. Is there a positive correlationship? Is there a negative correlationship? Is there no correlationship as such? So what is the relationship between the value that is represented on the x-axis and the value that is represented on the y-axis? This is the idea behind a scatter plot. The scatter plot depicts a tuple or two variables together and tries to show the relationship between these two variables. When we come to frequency distribution, it is about one variable and the frequency of a particular observation of that variable. So that depiction is different, this depiction is different. This is we are seeing what is the relationship between two variables as such, okay. That is about the frequency of one single variable. Now let us see what can we infer based on scatter plots, what can we infer about the relationship between two variables. So here we had one scatter plot, we said that there is a positive relationship. But what is positive correlation, what is negative correlation? Let's take a look at these terms and let's understand what is correlation, positive correlation, negative correlation, what does it exactly mean? So positive correlation, first let's try to understand what is perfect correlation. Perfect correlation basically means that there is an exact proportionality between y-axis and x-axis, that is y is k times x. If there is an exact relationship like that, that would basically mean that as x increases, y increases as proportionally with x. That is, if you draw a line, it will be a perfect line which will pass through all the points as such. If it passes through every single point and all of the points lie on a single line, then you would say that y can be represented as some multiple of x where k is some positive value. So because this k is a positive value, we can say that y is a positive correlation, y has positive correlation with x, basically meaning that some positive multiple of x as such. This value of k can be, it has to be non-zero, it has to be positive for positive correlation, negative for negative correlation, but the idea is that the value of k can be half, can be 2, and based on that you will have basically graphs that move slightly differently. So if you have, say, k is equal to half, you will have a flatter correlation. If k is equal to 2, you will have a more sloping correlation. But the idea is when you say perfect correlation, y can be every single point can be mapped to a single point on x, and there is a perfect relationship, that is a one single line passes through all the points as such, that is perfect correlation. And essentially if the multiple, if y can be expressed as a multiple of x such that that value k has a positive value, then it is positive perfect correlation. What is negative perfect correlation? In negative perfect correlation, you will have a negative relationship between y and x. Rather, what you can say is that y is some constant, say c minus k times x. Here, because k, the coefficient of x as such in when you calculate y is negative, because it is negative, you say it is a negative correlation. As the value of x increases, you are saying minus k times x, so the value of y keeps decreasing. Some constant value c minus k times x. So if you can express y in this particular relationship, because the coefficient of x is negative, we say that there is a negative correlation between y and x. So in a negative correlation, what do you see? You see a downward sloping trend. That is basically as the value of x increases, you deduct more and more from the constant and the value of y keeps on going down. So as the value of x increases, y goes down. In terms of positive correlation, as the value of x increases, y also increases. If you see the previous one, what can you say? You can say that this is a positive correlation. While this might not be a perfect correlation, it might not be that if I draw a line, it passes through every single point. What I can see is that as the value of x increases, that is as the age increases, y is increasing in every single case as such. So it is a very strong positive correlation. So positive correlation shows that as the value of x increases, the value of y increases proportionally. Similarly over here in perfect correlation, it has to increase proportionally. In a perfect correlation, negative correlation, it has to decrease proportionally. So if you can express it like this, where every single point, the line passes through every single point, it is perfect correlation. This is an example of positive perfect correlation. This is an example of negative perfect correlation. But generally when we actually measure data in real life, we never get perfect correlation. There is always some noise. There is always some factor which will slightly change the values. The few examples where you might get perfect correlation I have given over here. Response time versus number of requests. So basically what might happen is that your response time might be a function of number of requests. If there are more requests, you might take more time to actually respond back, and then you have basically response time increase proportionally with the number of requests. So if that happens, basically you have perfect positive correlation. On the other hand, if expense and savings add up to your income, since your income is like constant, okay, so your income is constant, So income minus expenses would be savings. So as your expenses go up, your savings go down. So there'll be a perfect negative correlation. So whenever you're trying to figure out, is it positive relationship, negative relationship, you have to see what is the trend observed. As X increases, does Y also increase? If it increases, then it means that X and Y are positively correlated. If it increases proportionately, or if it increases like very close to a straight line as such, then it is a very strong relationship. If it can be plotted on one single line, it's a perfect correlation. But in general, if you see that it is increasing in sync and it is almost close to a line, it becomes a strong relationship. So I'll give you an example of strong correlation. So over here you can see that there are many points. Not all points would actually lie on a line. If I try to draw a line, I would have to draw a line which somehow passes through the line points as such, but there won't be one single line which essentially connects all the points. If I try to approximate what the line would look like, it would be something like this, where it is passing through most of the points and other points are kind of near the line as such. But this is not a perfect relationship as such. But if you see, the points are more or less distributed around this line. So there is a positive correlation. We can see that as the salary is increasing, the savings are increasing. But they might not increase exactly in proportion, because sometimes what happens, as salary increases, sometimes expenses also slightly go up. So while savings in general increase with increase in salary, that might not always be the case. So basically what we see in this graph is that there is a general positive trend of increase in savings with increase in salary, but this correlation is not a perfect correlation, but it is a very strong correlation, because all of the points are very close to that line as such, which means that there is a strong positive correlation shown by these points, showing that there's a strong positive correlation between savings and salary. So essentially these points, the x-axis shows salary, the y-axis shows savings, and we can see that savings are very strongly positively correlated to salary, because all the points are fairly close to that line that is passing through all the points. If we can actually draw a line such that it is fairly close to all the points, we can say that it is a strong correlation. Similarly, over here we see a negative correlation, which is also a strong correlation. Why is this a strong correlation? We see that if I draw a line like this, most of the points are distributed along this line. They are not too far from the line as such. Because they are not too far from the line, I can say that I can roughly approximate how median house prices change with interest rate. As interest rates increase, generally the median house prices are going down. Why would that be the case? In general, we know in economics, as interest rate prices increase, the value of the asset depreciates, because it becomes more expensive to pay for the same asset as such. So the listing price has to come down for people to afford it. So as the general trend that is observed is that as interest rate prices increase, the house prices decrease as such. So what we see, there's a strong negative correlation between median house prices and interest rates. It might not be a perfect relationship. Sometimes, for example, over here you can see for the same rate, you have two different median house prices. Why would that be? So there might be other factors also that also contribute to median house prices. There might be the presence or the higher demand, less supply, a booming economy. There could be other factors that also contribute to the median house prices. But in general, interest rates have a negative effect on median house prices. So other things remaining constant, we see that there is a negative impact with rising interest rates. So we see a negative correlation between interest rates and median house prices. This is not perfect correlation. Every single point does not lie on the line, but most of the points are closely scattered around the line. So if I try to draw a line such that it passes through the middle of these points and most of the points are as close to the line as possible, I see that most of the points are fairly close to the line and there is a negative relationship. Another way we can actually figure out whether it's a positive relationship and a negative relationship, you know that as x increases, if it increases, y increases, then it's a positive relationship. As x increases, if y decreases, it's a negative relationship. But in general, what we can also say is that if you take a look at and join this angle with x-axis, for example, if I extend this line downwards and if I consider this angle with the positive x-axis, this is positive x-axis. This is the angle, say theta, with the positive x-axis. So if this tan theta is what? It is essentially the slope of the line. If tan theta or the slope of the line is positive, this slope of the line, if it is positive, it is a positive correlation. If I join this with the positive x-axis, this is the angle with the if I consider positive x-axis, it is beyond that, like it is beyond the space that we have, but essentially it will be like this. The line is like this. This is the positive x-axis. This will be the angle theta. This is the positive x-axis. This is the line as such. This theta would be a obtuse angle, and therefore tan will be negative. Because tan is negative, what will happen? The slope m will be less than 0. Tan theta, that is the slope of the line, will be less than 0. Now, since the slope is less than 0, the slope of the line is less than 0, we say that if the slope of the line is negative, it is negative correlation. If the slope of the line is positive, it is positive correlation. These are basically just ways of remembering whether it is positive or negative correlation, whichever is more intuitive to you. For some people, geometry is more intuitive, so you can figure out whether there is correlation or not based on the angle that is between the line and the positive x-axis, or just by the simple intuitive fact that if x increases, y increases, it's positive. If x increases, y decreases, it is negative. Okay, so these are examples of strong correlation, positive correlation and negative correlation as such. Now let us consider weak correlation. What is weak correlation? So weak correlation is basically showing a trend, but the trend is not a very strong one. Why is the trend a weak one? So basically, if I get a graph like this, I can see roughly that as the height increases in inches, so this is height in inches, as the height increases, roughly the body weight is also increasing. But there is no exact relationship between them. So if I try to draw a line, I can draw a line like this, I can try to draw a line slightly. It will be difficult for me to also draw a line because there is no exact line that can be approximated based on the data points that are there. So generally I see that there is a line, there's a positive trending line between the points as such. But if you see, the points are fairly far away from that line. There are firstly multiple lines possible, and these points are very far away from the line. Why is that the case? Basically, for the same height, you have very different body weight. Somebody who is shorter can have a low body weight. Somebody who is shorter can also have a high body weight. Somebody who is taller can be very thin and can have a low body weight. Somebody who is taller can also have a very high body weight. So while there is a general trend that as height increases, there is an increase in body weight, this trend is not a very strong trend because there's a lot of variation at every different height values. We see a lot of variation in weight values. So this is a weak correlation between height versus weight because the points are very far away from the trend line. Again, it is difficult firstly to draw a trend line because there is no one clear line which can go through the middle of all the points as such. So firstly, while there is all the lines that you will draw will be positive sloping lines, so there is clearly a positive correlation. The points are so far distributed from those lines that I would say that this is weak correlation. If the points are close to the line, it is strong correlation. If the points are further away from the line, so it is kind of like this thick, and the line is here. If it is like a thick tube around that line, then it is a weak correlation. If it is a thin tube around the line, so this is the line and there is a thin tube around the line. The thinner the tube, the stronger the correlation. If the tube around the line is very wide, the points, if I consider the area of the points around the line, if the area of the points around the line is very wide, then it's a weak correlation. If suppose this is the line, if all the points are very concentrated in and around the line, it's a strong correlation. In this case, while the trend is generally positive, it's a positive correlation because they are kind of like spread out away from the line as such. The variance from the line is higher, and because there is like clearly that the points are fairly away from the trend line, we can say that this is a weak correlation. Now, why does weak correlation and strong correlation matter? See, basically the idea of strong correlation and weak correlation is that if I see a trend roughly like this is the trend, I can basically draw a line and say that y is say 6 times x or plus 3 or something like that. I'll give a general formula for what is the value of I given the value of x. Now the idea is that if I give a formula like that, I can predict even when I do not have values of x. If I say have ages, like for example in the previous cases I had different salaries and savings, and I have a trend line which is say suppose say salary is say 0.4 times, so savings is say 0.4 times salary or something like that. So savings is say 0.4 times salary. Now what can you do if you actually figure out a relationship like that? You can predict in the future. You can predict in the future saying that, okay, if salary is 200,000, I would expect savings to be 0.4 times that. So I expect savings in that case to be around 80,000. If it is 1 million, I expect the savings to be around 400,000. So if correlation is strong, the accuracy of your expectation is strong, the accuracy of your result, the expected value is higher, because there is very close relationship between the points observed and the predicted line that you have. If the lines or points are fairly widely spaced, then the accuracy of your prediction is weak, because you can't say for sure. Over here also at 70 inches, I can't say for sure what the body weight will be, because it can be fairly widely apart from that line as such. So why is it weak correlation? It is weak correlation because its ability to predict is very weak. It is poor. The points are too far away from the line. I cannot say with any real reasonable accuracy what the expected value will be. So that is also why there is a weak correlation. Over here also, if you see crime rates versus median rent, you see as the median rent increases, the crime rates actually go down. I can draw a line something like this. But what you can say is that at certain points over here, these are so far away from the median rent, that line as such. So can you really predict what the crime rate would be based on the median rent? No, because the distance of these points, especially at the lower rent values, is far away from the line. So I would say that even if I draw a line like this, I cannot say with any reasonable accuracy what the relationship between the crime rates and median rents are. Though there is a negative relationship, it's a weak negative relationship, weak negative correlation, and we cannot say with any certainty what the relationship will look like, because this is a weak correlation. The points are too far away from the line. So this is the idea of what is strong correlation, what is weak correlation. The idea is that you find out the relationship, find out whether it's a strong correlation, weak correlation. If you can figure out what would be the equation of such a line. See, when you draw a line like this, it has a slope, it passes through some points, because there are some points on which it passes. X and Y coordinates of those points are available. If you consider that X and Y coordinates of these points are available, what would be an equation of the line that passes through these X and Y coordinates? You can find the equation of the line. So suppose if I say that Y is 20% minus, say, some multiplier of 10% of median rate. So if suppose something like this, I can find out a formula like this. But does it make any, can I predict with any real accuracy what the value will be based on a formula like this? I'm not sure this is correct, but essentially something like this, if you have where is some multiplier of median rent, 20% minus some multiplier of median rent. The idea is that it will be a very poor predictor of what the actual value will be, because it's a weak correlation. If you have strong correlation, your accuracy of prediction is high. With weak correlation, you can't really say anything. So this is the basic idea of what is strong correlation, weak correlation, and the use of correlation to predict values when values are not known. So you basically see the trend, you draw a line, you figure out the equation of the line, and that equation can help you find out values of y when for x, like x and y values where you don't have them. So for example over here, suppose if I don't have the value of x and y for say $4,000, I can find it out with the equation, but with poor accuracy, because this is a weak correlation. Similarly, over here in case of strong correlation, I can find out the savings for 200k. Though that point is not known to me, I can predict it based on the information I already have. So one of the reasons why we have correlation is to use it to predict the points whose data we don't have as such. So this is strong correlation, this is weak correlation. In general, remember, if you can draw a straight line passing through the middle of the points and the line is like such that all points are very closely hugging that line, it's a strong correlation. If the line is such that all the points are slightly far away from the line, there's a broad tube around the line or an expanding tube around the line, it is a weak correlation. Okay. Now consider the case of no correlation. Consider if you have number of traffic violations, the example of number of traffic violations versus income. On x-axis we have income, on y-axis we have the number of traffic violations. We see that at different incomes we have different number of traffic violations. Those with lower income have sometimes low traffic violations, sometimes high traffic violations. Some people with high income sometimes have low traffic violations, sometimes have high traffic violations. So clearly there is no trend visible from the graph as such. I can draw any line, I can draw a line like this, I can draw a line like this, I can draw a line like this. It can be positive, it can be negative, it can be zero also. So in general, basically there is no trend observed. If there is no trend observed, there is no correlation. Essentially, we cannot predict how many traffic violations somebody will have based on their income, because a high income person can also have a lot of traffic violations, while the same can be said about a low income person also. So these two variables, number of traffic violations and the income as such, are uncorrelated. So if you see any graph like this, a scatter plot like this, where you can't draw any trend line, where you can't say where a positive trend line is possible, a negative trend line is possible, a flat trend line is possible, any kind of trend line is possible, you would say this would be an example of no correlation. Then you can say that nothing can be said about the relationship between X and Y, because they are not correlated to each other. Okay, you cannot predict the value of Y based on X or X based on Y, because there is no relationship between them. Okay, so this is the basic idea of correlation. Now, one more thing that I need to make clear is that sometimes the paper setters in GMAT might actually put a trap for you. Sometimes we might see that, okay, there is a clear correlation between the points, okay, say like this, where there is savings and say salary. Okay, so income or savings, there is a positive correlation. So is this, does this positive correlation mean that there is causation, that higher salary leads to higher savings? We can say yes, and probably in this case, higher salary does lead to higher savings, because the more money you have, the more ability you have to actually put away more. So in this case, causation is actually there is not just correlation, but there is also causation. The savings are enabling you to, the salary is enabling you to save more, but that might not always be the case, for example. So for example, consider some of the other cases where we see the correlation, but we don't see causation. So for example, consider the earlier cases. Over here you had body weight versus height. It was a weak correlation. Would you say that your height is responsible for your body weight? Not necessarily, because not just your height, your eating habits, your exercise habits, all of them are actually causing your body weight. So it is not your height alone which can be said to be the cause of your body weight. Similarly, crime rates versus median rent. Can you say that the median rent is responsible for lower crime rates? No. Even if this was a strong correlation, you can't say that median rates is the cause of lower crime rates, because there might be a third cause which might explain both of these factors. That if a neighborhood is safer, it would have higher median rent and lesser crime rate as such. There might be neighborhoods which are in general where people with higher income are staying. So they would pay more rent and they would have less likelihood of encountering crime. So there might be, it need not be that even if something is correlated, that A is the cause of B or B is the cause of A. So we can't say that crime rates are the reason for the rent, or the rent is the cause of the crime rates. Neither way we can tell, because there can be a third cause as such. So not all correlation, the idea is not all correlation is causation. Just because you have correlation does not mean that there is causation. X causing Y or Y causing X cannot be inferred just from the correlation spot. So at max you can say that X and Y are correlated either positively or negatively, or X and Y are uncorrelated. There is strong correlation or weak correlation. You can say nothing about causation just from the scatter plot as such. In certain cases there is causation, in certain cases there is no causation. But just from the scatter plot, can you tell that there is causation? No. We can basically not comment anything about causation from the correlation scatter plot as such. So essentially, what trap they might actually set in GMAT is that they will give you sentences. So in general, we can say that X is causing Y. Can you say that? No, you cannot infer anything about causation based on the correlation as such. The only thing that you can say that they are likely to occur together, but X causes Y, we can't really say. Okay, so this is the basic idea behind correlation is not causation. In general, any statement where you get the below a scatter plot where two correlated things are given, and wherever the statement says that X is causing Y, or X is the reason for Y, or X is the factor which is causing Y, we should basically just say cannot be determined. Another thing that they might ask you is that based on this scatter plot, can you predict where the next value will be? You can predict, but you can't say that X caused Y. Prediction is possible. Prediction based on the calculated value of that line, you can predict, but you cannot assign a cause for it. That you should be very, very clear about. Okay. So now we come to descriptive statistics. This is, I wanted to basically discuss descriptive statistics before we go to frequency diagrams and frequency distribution. So what are descriptive statistics? What exactly you should know? So firstly, I said that each type of distribution that comes in GMAT is different. The first one has a tuple of data. This one, where you have frequency distribution tables or frequency diagrams, it's not a tuple of data. It's not two variables information that is given, but rather one variable information that is given, or rather a set of values is given. So instead of giving you age versus height, they'll just give you age. So age of all people who are working in a company, for example. So you will have a set A of values which are ages of everyone who is working in a company. So you will have, say, these set of people that are working there. So this is there are, say, 4, 8, 9 people that are working in the company. This is the set of all ages of the people that are working in the company. So essentially, this is just one variable information. In this particular scenario, you can essentially convert this set into a frequency table where you can say that, let us consider how many people are there by age group. So you can say that less than 30, between 30 to say 40, and say greater than 40. So greater than 40 as such. So consider these three different subsets of the same set as such. So now how many of them are under 30? So you have 1, 2, 3 which are under 30. How many are between 30 and 40? 1, 2, 3, 4 are between 30 and 40, which would mean 2 are above 40, which is correct. This 1, 2 are above 40. So this is basically, we can convert a set of data into a frequency table like this. So this is the frequency distribution, this is the range, and this is the frequency of occurrence, or how many times basically these values occur in this particular range. You can express the same thing in terms of a diagram. You can say that, okay, under 30, how many are there? Between 30 to 40, how many are there? And above 40, how many are there? You can show by a diagram also. You can say that, okay, this is, say, 1, 2, 3, 4. You can say that this has to be a bar which is 3 high. This has to be a bar that is 4 high. And this has to be a bar which is 2 units high. Now, this is for a fairly small set of data. Now, suppose you consider not just the number of employees in a small startup, but suppose you consider the ages of all people in a city. Now, that would be a huge amount of data, right? So, when you have ages of people in a in a city, for example, then you will have that, okay, it goes from 0 to say 100, and there are many bars like this. So over here, what you have is you have a distribution diagram, a frequency table or a frequency distribution diagram. Or if instead of showing these bars, we can just basically connect these values together and show a graph like this. This also is basically a frequency graph, a histogram as such. Now, this information just shows the frequency at which a particular number of times a particular observation occurs. So when you are given a either a frequency table or a frequency diagram or a histogram chart like this, what is generally asked is that descriptive statistics on these are asked. So you'll be asked questions on range, median, mode, etc. So let us take a look at the values for this, like range, median, mode, for a small set of data where it is easy to calculate. And then the same thing can be applied to larger sets of data where information might be there in the form of a table, a big table, or even a chart, continuous chart like this. So first, let us take a look at the same descriptive statistics for this small set of data, and the same idea can then be applied to larger sets of data. So let us first take a look at the what is range. So what is range in a given set? So range in a given set is basically the largest value of the set minus the smallest value of the set. So for the above set that we have ages of people working in a company, what is the largest value? 44 is the largest value. What is the smallest value? The smallest value I see is 21 over here, minus 21. So what is the range of the given set? The range of the set A is 23. So essentially, if you are given a frequency set like this, you can say that range is basically the largest value minus the smallest value. Suppose you are given a frequency table like this, okay? If you are given a frequency table where you are given, say, values so that say 0 comes, say, 1 time, 1 comes, say, 5 times, 2 comes, say, 3 times, and so on, and finally, say, 18 comes, say, 1 time. So what is the range of this frequency table? In this, what is the value of that element as such? What is the largest value of any element of the set? 18 is the largest value as such in this set, because here basically if I expand this frequency table into a set, I will have that 0 is there once, then 1 is there 5 times, 1, 1, 1, 1, then 2 is there some number of times, and finally 18 is there in the last value as such. So the range of this set will be the largest value 18 minus the smallest value, that is 0. So 18 minus 0 will give me that the range of this frequency diagram is 18. Suppose instead of being given a frequency diagram, suppose if I am given a frequency bar graph as such. Again over here, if I am given a frequency bar graph. So suppose in the frequency bar graph, I am given that, okay, these are the values, these are the bars, etc., etc. How do I find out the range? This largest value minus this smallest value is the range of the graph. That's it. Okay. Now suppose if I am given a frequency table, but instead of being given a exact value, I am given a range of values. So for example, when we had under 30, 30 to 40 and above 40, suppose we are given something like this, okay. So if you are given range of values like that, suppose the same thing I will put under 30, 30 to 40 and above 40. Suppose if you are given information like this, it would be difficult to tell you the exact range because the lowest value, that information of the lowest value is missing. Under 30 can be equal to 1 year also, 18 years also, 21 years also. So you don't know exactly what the lowest value is. Similarly, above 40 can be a 100-year-old person also. So you don't know what the highest value is. So in this particular case, what we can tell is what is the, because the maximum range, we can either say what is the maximum possible range or the minimum possible range. Suppose you have to find out the maximum possible range. That would be basically the highest possible value over here, which is above 40. So it can be 100, 120, we can't say. Lowest possible value over here, it can be 0, but because these are number of employees working in a company, would at least be 18. So again, maximum value cannot be properly defined. But can we find out the minimum range that will be there? Minimum range, since this is less than 30, the maximum value that can be there in this particular age range will be 29. So the smallest possible value can be 29 as such. Similarly, above 40, what is the smallest possible value above 40 as such? That would be 41. So the least possible range, at the very least, there will be 41. If there is somebody, say there are 3 people over, like 3 people over here, 4 people over here, 2 people over here. The least possible case would be there are 2 people with 41 age and there is say 3 people with 29 age. In that particular scenario, the minimum possible range is 41 minus 29. So this is equal to 12. So while we can't exactly tell the maximum range, in a case where ranges are given instead of actual points of value, we can tell you what the minimum range is. So range is essentially has to be found out in this way, largest minus smallest value. If exact values are not known, if range of information is given, we can take we can either calculate the maximum possible range, which will generally be, there will be no limit to it, or the minimum possible range, which we can actually find out with a fairly reasonable limit. So this is basically what kind of questions that can come based on descriptive statistics on frequency diagrams. Then with the same thing, let us take a look at the same set and let's try to identify mean as such. What is mean? Mean is basically the arithmetic average. The arithmetic mean or arithmetic average is basically the mean of any set. In this particular set, we just have to add up the 9 elements, divide by 9 and we get the arithmetic mean. In this case, these seem to be kind of distributed around 35. So I'd say this is minus 14 plus 2 minus 2 plus 9 plus 8 minus 8, 35 plus 8, 35 minus 8. Minus 7, minus 4, minus 2. So over here, this will cancel with this. This cancels. So you have minus 14, minus 6, so that is minus 20. Minus 20 plus 2 is minus 18. So minus 18 is the divergence from 35, divided by 9, it is minus 2. So the actual mean would be 35 minus 2. So that would mean that the actual mean or actual average is 33. I use the diversion method to calculate the mean, but you can just add up 21 plus 37 plus 33 to find out. Here I assume the mean to be around 35. I found out the difference of each element from 35. So 21 is 14 lesser, so minus 14. 37 is 2 more, so plus 2 and so on. So it's a quick way of finding out the mean, but essentially you have to take the sum of all the elements, divide by 9, you get the answer as such. So in this particular set, the mean or the average age is 33. Now suppose if instead of being given a set like this, suppose you are given a frequency table and a large frequency table at that. So can you quickly find out what is the value of mean? It would be very difficult to do. So mostly they will not give you any reason to calculate mean with tables as such. But suppose instead of a frequency table, you are given a frequency diagram like this. Can you tell the mean of this particular distribution? would be still difficult to say, but you can take an educated guess that the mean would be somewhere near the median. The median would be basically the middle value, if especially in a bell curve like this peak as such is the median of that particular distribution. If you have a normal distribution or any kind of bell curve, the median is the middle part or the peak of that distribution, and the mean would be roughly equal to the median when it comes to a standard distribution or a normal distribution as such. So from that you can take a guess that somewhere around this the mean would be, but you can't exactly calculate, especially with a large number of points. It would be difficult or nearly impossible to calculate in an exam environment, but you can take an like a guess that the mean would be somewhere around that median, especially when a bell curve is given. Now what would be the median of these values? Again, if you consider the same set as such, how do you calculate the median? Again, what you have to do is arrange them in an ascending order. If you arrange them in an ascending order, you get the set 21, 27, 28, 31, 33, 33 comes twice, 33, 33, 37, 43, 44. These are the 9 values. You have to then say what is the middle value. The middle value is 33. So the median in this case is 33. For a small set, it is easy to find. For a large set, can you find out very easily what the median is? If you are given a frequency table, you can try to find out what the median value will be. So if you can say that add up the total number of frequency points as such, suppose you surveyed 100 people. So if you can see where the 50th observation will be like, then you can find out the median. So of the 100 people, you can say that okay, first two values take up to 30 people. Next value takes up to 20 people. So this observation over here is likely to be the 50th observation, which means that it is going to be the median as such, 50 and 51st observation. So that is likely to be the median. So you can arrive at an educated guess of where the median would be, even in a frequency table, by looking at the distribution as such. If it is kind of in the middle where there are equal number of entries at the top or the bottom, or you can count till like 49, 50 entries, then you can figure out what the median value will be. So this is the basic idea of how to calculate the median even on a frequency table. In a frequency diagram like this, the median will be, if it's a bell curve, it will be the middle value, which is over here. The peak would be in a normal bell curve or a normal distribution, the peak is the median as such. So from that also you can directly read what the median values would be. Now what is mode? Mode is basically the median is basically the middle value. If you take a set and you sort it and you find the median value, that is a median. So again, in all of these distributions, I am assuming that there is a certain amount of symmetry. If there is a skewed distribution, it's not easy to find the median or the mean also. Arithmetic mean and median cannot be found over there. So if you have a normal distribution, then you can actually use your eyes to find out the median and mean. Otherwise, if it's a skewed distribution where you have a distribution like this, nothing can really be said about the mean or median by just looking at the diagram. Okay. Now suppose you have to find out what is the mode. Mode is basically the observation that comes the most number of times. So for example, in this particular observation, all the elements come once, only one element comes twice, which is 33. So 33 is the mode of this set. If you have a frequency diagram, a frequency table, any observation which has the highest value. So suppose that say this is 0, 1, 2, 3, 4, 5, 6 and 1 suppose comes 30 times and nothing else comes 30 times as such, then you can say that 1 is the mode of this set. In a frequency diagram, if you have something like this, the observation which comes the most number of times is the mode of the distribution. Suppose if you have a distribution like this which has twin peaks, okay, twin peaks of equal height as such, then this is called a multimodal distribution because it has two modes as such. So mode also can be visually seen in any distribution, which is basically the point at which the frequency diagram peaks. The absolute peak of the frequency diagram is the mode of that distribution. Okay. Now standard deviation in a particular set. I will explain in terms of understanding variability and understanding variance, but standard deviation calculation etc. will not be needed over here. It will not be needed in data insights. It will not be needed for graphical interpretation. So what is standard deviation? So in this case, let me just erase a bit. So consider the set that is given, okay. In the same set that is given, standard deviation or variance is basically, I will just tell you the intuitive meaning of variance. So you have this set, when you arrange it in this particular order, you have this particular set. You have an arithmetic mean, you found the arithmetic mean to be 33. Okay. Now, if I consider what are the variance of each point from 33, what is the variance of 21 from 33? It is 12. Variance of 27 from 33, it is 6. 28 from 33, 5. 31 from 33, 2. 33, this is 0, 0. This is 4. This is 10 and this is 11. If I take a square of this and add it all up, this is basically minus 12, minus 6, minus this, minus, and then plus 4 plus 10. So basically if I take 21 minus 33, 27 minus 33, these are the values that I get. This is basically the element E minus the mean as such. This is the value that I have calculated for each element in the set. Now if I take the square of it, that I'll get 144, this is 36, this is 25, this is 4, this is 0, 0, 1600, 121. If I add it all up, divided by 9, I basically get an average variation or square of difference from the mean as such. If I take a square root of it, I get the variance or the standard deviation of this particular set. So what does standard deviation essentially mean? It means that if you have a mean, how far are the points from that mean? If the points are very close to the mean, all points are very close to the mean, the frequency diagram would be a narrow peak like this. In that particular case, the variance is low, the standard deviation is low. If the points are spread out around the mean, in that case, the distribution is flatter. It is more, it is kind of, you push it down, it moves, it is wider, it is flatter. Things are not crowded around the mean. In that case, the standard deviation is larger because the points are further away from the mean as such. So essentially, what is standard deviation or what is variance in terms of intuitiveness? If all points are very close to the mean, then it is a narrow, tall kind of a distribution. Then standard deviation is low, variance is low. If it is kind of spread out from the mean, it is kind of a flattish curve as such. It is more spread out. It is far away from the mean. Then it has a high standard deviation and high variance. Okay, this is the intuitive understanding that you need to have. You do not need a detailed understanding of normal distribution. All of that is really not needed at all. But an intuitive understanding of what standard deviation means when it comes to graphs, what is the mean, median, mode when it comes to graphs will definitely be helpful. But a very in detail understanding of graphs where you have a how to calculate standard deviation of graphs, etc. is not needed. Just know that narrow and tall, low variance, low standard deviation, broad and squat, high variance, high standard deviation. Now let us take a look at the different things that I have mentioned till now. So consider frequency distribution. So in this case, we have a table, height in centimeter and how many times it occurs. Suppose this is like the frequency distribution of the height of students in a school. So we see that this also has like a bell curve shape, mostly like it is peaking around 98 and then again falling off. Because generally we would observe something like this. Not everybody, it won't be like everybody is like getting taller and taller and the tallest guy is like the most common. We generally see that there will be in most things that are observed in day-to-day lives, there is a bell curve shape for many things, because when you have heights, most people tend to be around in and around average, where both extremes are rarely seen. Very short people are rarely seen, very tall people are rarely seen. Most people have a average height that is seen, and that occurs most number of times. So this is something that you'd see many times in life as such. So you would have a frequency distribution table like this. So from this frequency distribution table, can you tell what is the range of this table? What is the range of frequency? So range of frequency, the highest value is 103, the lowest value is 92. So what is the range? The range is 21 centimeters. What is the mean and median? So mean, I would have to actually take the arithmetic mean, which would not be asked in data insights because it would be too time consuming, because basically I would have to say 92 into 1 plus 93 into 1. I'd have to take a weighted average. 94 comes twice, so 94 plus 2 plus the sum of all this. So all of that would be required to calculate the arithmetic mean, which would definitely not be asked. But they can ask you the median, because essentially what do you have to do in median? So you have to say, okay, this is how many frequencies this is 4, this is 4, 7, 11, 16, 22, 27, 32, 35, 37. So there are 38 values. So essentially the average of the 19th and 20th value will give me the median. So what is the 19th value? This is 4, this is 7, 11, 16, 16 up to this is 22. So 19th and 20th value both are 98, which means that the median has to be 98. So just by counting where the middle value is going to be, I have found out that the median is 98. in general also, I can say visually that the mean might not exactly be 98, but it will be close to 98. It is not going to be, it is definitely going to be closer to 98 than it is going to be closer to 92. Okay, so the median I can find out in such a frequency table. I can easily find out that the median is 98. What would be the mode? Again, the mode is the value at which the graph peaks, which is again 98, or even in the table the value which has the highest length, so that is again 6. So the mode is also 98. Now consider standard deviation. Does this have higher variance? So if you are given two curves like this, suppose you are given two bar charts, suppose a third bar chart is given, second bar chart is given, where you have like another bar over here, here, and over here, and suppose some just a small bar chart like this is given with just 5 values. Now which will have more standard deviation? Since this one is narrower and taller, just like very close to the mean, it is going to have low standard deviation, low variance. The other distribution which is flatter will have higher standard deviation. So while we don't need to calculate, we can say which is going to be more, which is going to be less. Okay, this is the basic idea of what can be asked given a frequency diagram or a frequency distribution. Now let's take a look at range-based frequency distribution. So in these kind of questions, you might be asked to find out the maximum value or the minimum value, the modes that are there, how many modes are there. So in this particular case, let us take a look at so you are given the score range, okay. So you are given the frequency of scores. So how many people scored between 0 to 10, how many scored between 10 to 20, 20 to 30, 30 to 40, 40 to 50 and 50 to 60. So if I see the distribution there, I can see that there are 20 people who scored between 10 to 20 and 40 to 50. But can I find out the mode of the set by is? No, because range of value is given, I can't find the mode of the distribution as such. But I see that the mode of the distribution can, the values are kind of concentrated between 20 to 30 and 40 to 50, and somewhere around this the mean and mode and median would be somewhere around this. Again, the mode can be in 50 to 60 also. If 51 comes like 5 times and everything else comes only once or twice, the mode again will be in 51. So it doesn't matter, just looking at this bar, we can't tell where the mode is. But we can say that median has to be somewhere around between 20 to 50, median will be somewhere around that. We can calculate it properly by saying that, okay, how many total are there? This is 7, 27, 42, 62, 72 values. So where is the 36th and 37th value? This is 27. 27 plus 15 would be 42. So 36th and 37th value is over here. So the median has to be in 40. So this has to be where the median is, which is between 30 to 40. So the median has to lie in the 30 to 40 range for sure. It cannot be in the 20 to 30 range, nor can it be in the 40 to 50 range for sure, because that value, the middle value, is in this particular range. The median has to lie in that particular range. Now we can't tell the mode without the actual values because this range of information is given, but the median can be figured out. Again, mean cannot directly be calculated until we actually take the actual value, add it up and calculate it. Again, standard deviation, just from this we cannot say. If we have another graph, we can compare the standard deviation of this graph with that graph, but again with a multimodal distribution like this, it will be difficult to tell what would be the mean or standard deviation or anything of that sort. So basically from this we can't infer much other than median. So if a range of this is given, the only thing that we can really say, like range based frequency distribution is given, we can figure out what the median is. The other thing that we can figure out is the range. Basically we are given 0 to 10 and 50 to 60. We can find out what is the minimum range of values. So if it is 0 to 10, okay, and if it is like say 0 less than and less than 10. So if it is less than 10 and this is say 50 to less than 60. If these are the range of values, for example, what is the max range that is possible? Max range that is possible is that the one of these two gets 0. So the lowest possible value is 0. And the last possible, since this is less than 60, the highest possible value is 59. Nobody got a perfect score, say. So 59 minus 0, the max range would be 59. What would be the least possible range? Now you have two people in 0 to 10, this has to be less than 10. So the highest possible low value would be 9. So both suppose get 9 marks as such. So both of these have 9 marks. So the lowest value is 9. Over here, what is the least possible value in the highest range? Suppose all 10 get 50. So it would be 50 minus 9. So the min range in that case would be 41. The max range in that case would be 59. So using a frequency distribution table like this, we can figure out what is the median value what is near the range of median value, and we can also figure out what is the max possible range and min possible range of all values as such. So this is something that can be done with a range based frequency distribution table or frequency diagram also. Now let's consider median and standard deviation, especially when you have bell curves. What can you talk about median and standard distribution? I have discussed this earlier, but something that I wanted to reiterate by showing different graphs. Now from these three curves, pay special attention to the gray curve and the yellow curve. So can you tell me something about the gray curve's median or mean? The mean would be where the gray curve peaks. It's a normal distribution, so it would be somewhere around here. Similarly, the yellow curve is also showing a bell curve normal distribution kind of this. So mean or median would be also over here. So from this, can you infer about the relative means of these two distributions? I can say that the yellow mean is greater than the gray mean. So in general, I can say that the yellow distribution's values on average are greater than the gray distribution's values on average. Not every value will be greater. So the yellow point over here is less than the gray point over here. But on average, because the mean is further from the gray mean, on average, the yellow distribution's values will be greater than the gray distribution's values. Another thing that you can actually see, consider the gray curve and yellow curves. So if you see the blue curves and the yellow curves, the blue curve and the gray curve have similar flatness. They are kind of fat, squat, spread out. The yellow curve is tall. It has a nicer peak. It is more concentrated around the mean. The points are closer to the mean. So what can you tell about the standard deviation of such? I can say that the standard deviation of the yellow curve is less than the standard deviation of the gray curve as well as the blue curve, because the gray curve and blue curve are flatter. They are more spread out. So there is more variation around the mean. The yellow curve is more closer to the their mean. So that would mean that the standard deviation and variance is lower. So directly this might not be asked, but basically knowing these kind of descriptive statistics, how to find range is needed, range is asked. Mean and median might be asked given small sets of information. Range is definitely asked, mean and median might be asked. Standard deviation, knowing it is good because they might ask you about variability. That does it show more variability, does it show less variability? Less likely to occur but can occur. Mean, median, mode also can be asked given a frequency diagram. If they give exact values, even mode can be asked. So these are the basic things that you should know about frequency distributions, frequency diagrams, and how to answer descriptive statistics questions on the same. So let us take a look at a few questions based on it, both when it comes to correlations as well as distributions. So consider the following a relationship between the number of hours spent studying daily and the students' exam scores in a particular subject over several semesters has been shown in the charts below. The trends observed in the case of two students A and B have been mapped here. The data reveals a strong positive, no or strong negative correlation between hours dedicated to studying and exam performance for student A or B, indicating a highly predictable relationship between these variables. However, this correlation is notably weaker for the some student. So basically, let's take a look at both scatter plots. See A's scatter plot. Now all the points are fairly close to the line. They are hugging the line. They are very close to the line. So I would say that the line is mostly passing through all of the points, and all the points that it is not passing through are also very close to the line as such. So this is a very strong correlation. Is it a positive correlation? Is it a negative correlation? As the number of hours spent increase from 1 to 2 to 3 to 4, the exam score is also increasing, which means that this is a strong positive correlation. Consider the exam score for B. In case of B, while the trend is positive, the line does not pass through many points and many of the points are further away from the line. There is some distance between the points and the line. So when it comes to as compared to A, we can see that while there is still a positive correlation, because the points are further away from the line, it is a fat tube of points around the line. This is a weak correlation. Now, A has a strong positive correlation, B has a weak positive correlation. So between them, you can say that this is either a strong positive, no, or strong negative correlation. We can see that in both cases, there is a positive correlation. In both cases, there is no case where there is no correlation or strong negative correlation. So these two can be eliminated. So between hours dedicated, so which one has a strong positive correlation? So there's a strong positive correlation in the studying and exam performance of student A, not student B. Student B has a weak positive correlation, indicating a highly predictable relationship between these variables. However, this weak correlation is notably weaker for student B. A has strong positive correlation, B has weak positive correlation. So this is the right answer. See the graph, see how the points are there along the line, see the slope of the line, see whether it is pointing upwards, pointing downwards. From that you can figure out whether it is a strong correlation, weak correlation, positive correlation, negative correlation. So this is basically how you should read correlation and scatter plots. Consider the next question. The following chart shows satisfaction scores that were collected from 100 customers who recently purchased either premium or deluxe headphones from a leading electronics store. The satisfaction scores were obtained through post-purchase surveys conducted within a month of their headphone purchase. Customers were asked to rate their satisfaction with the product on an integer scale of 1 to 10, with 10 being the highest satisfaction level. So you have basically 100 customers and the scores have varied from 5 to 9, 5 to 9 as such. This is for premium headphones, this is for deluxe headphones. The average satisfaction score of the bottom quartile of premium headphones exceeds that for deluxe headphones by how much? So over here, if I consider, this is around 6, this is exactly 15, this is 24, this is 30, this is how much? This is 25. So this is 21, 45, 75, 25. So total 100, so it adds up. So everyone has scored between 5 to 9. Consider the next one, this is 8, this is 26, 27, 28, this is 28, this is 30, this is 21 and this is 2 lesser than 15, so that is 13. So how much is this? This is 36, 66, 87, 100. So all of these are also adding up to 100. So this is the total responses. All the responses are there in the graph as such. So what would be the bottom quartile when it comes to premium headphones? That would be basically the lowest 25 scores. This is the average satisfaction score of the bottom quartile. So 6 of the bottom quartile have given a 5 score. 15 of the bottom quartile have given a 6 score. Now this is 21. So 4 remaining have given, of these 4 out of 24 have given a 7 score. This adds up to 25, which is the bottom quartile. Quartile is basically 1/4. Since there are 100 respondents, bottom quartile would be the lowest 25 scores. So the lowest 25 scores, lowest 6 scores are 5. The next 15 lowest scores are 6 and the remaining 4 lowest scores are 7. So what is this average? This is basically 6 into 5, so that is 30, 15 into 6, that is 90, 7 into 4, that is 28. This sum is equal to 148. So 148, what is the average score for 25 people? So this is 148 divided by 25 into 100%, or just like leave it at 25. So multiply by 4, I get this is 560 plus 32. So that is 592 by 100. So the average bottom quartile score is 5.92 as such. So for the premium headphones, the average bottom quartile score is 5.92. Now let us do the same thing for the deluxe headphones. Let's see what are the lowest 25 scores as such. Okay, that is the bottom quartile score for deluxe headphones. So over here, the least 8 scores are 5. The remaining, we need only 25. We don't need all 28 of these 6-point scores. We need only up to 25 as such. So from these 28, we'll take another additional 17 scores so that our total is equal to 25. So these 17 scores out of these 28 are 6. So this is 8 into 5, so that total is 40, 7 into 6. I am multiplying because that is the number of times it is occurring. 6 score is appearing 17 times, 5 score is appearing 8 times. So 5, 8 times is 40. 6, 17 times is 17 into 5 is 85, 102. So this is 102. So this is 142. 142 divided by 25 multiplied by 4 multiplied by 4. So I get this is 568 divided by 100. So this is 5.68 as such. So this average score is 5.68. This is 5.92. What is the difference between the scores? So that is 5.92 minus 5.68. So this is 8 times, this is 4.24. So the difference is essentially 0.24. So the average satisfaction score of the bottom quartile of premium headphones is 0.24 more than the average satisfaction of the bottom quartile of deluxe headphones. So the correct option to choose is 0.24. Let's do the same for the next question. It can be understood that the median value of satisfaction scores for deluxe headphones is, so where would the median value be in this case? So let's remove all of this. So we want to find out the median value for the deluxe headphones and the premium headphones. Median value would be the average of the 50th and the 51st value. Where is the 50th value? This is 6, this is 15, so that is the 21 values are done, plus 24, that is 45 values are done. So next is 30. So from 46th to 75th value is basically the 8 score. So basically if I expand this out, right, 5 will come 6 times, okay, then 6 will come 15 times and so on. So the 46th value to 75th value will be 8. So what will be the median in this case? The 50th value will be 8, the 51st value will also be 8. So the average of 8 and 8 is 8, which means that the median score in this particular case for premium headphones median is 8. Now let's do the same thing for deluxe headphones. What is the median value? So the lowest 8 values are 5. The next 28 values are 6. So 36 values are done. Now from 36, 37 to 66, there is 30 values over here. So from the 37th value to the 66th value is just the 7 score. So what is the 50th value? 7. What is the 51st value? 7. So what is the average of the those two values? Again 7. So what is the median of deluxe headphones? So the deluxe headphones median is 7. So how much is it greater than, less than, equal to? So we can see that the median value of deluxe headphones is lesser than the median value for the premium headphones. So the median value of satisfaction score for deluxe headphones is less than that for the premium headphones. So the correct option to choose is less than. The deluxe median of deluxe values is 7. That of premium headphones is 8. So it is less than. So the correct option to choose over here is less than. Now let's consider the frequency diagram like this. So consider the following chart. Presents a comparative analysis of tree height distributions between forest regions A and forest region B. By examining the patterns revealed in the distribution graphs and accompanying data, conservationists can gain a deeper understanding of the structural composition of these forest ecosystems. So now we have a forest region A and a forest region B. Now we are asked in the statements, forest region A generally has shorter or taller trees as compared to forest region B. Can we say generally? Generally means what? Generally means mean or median. In case of bell curves, they'll be roughly equal to each other. So in general, what is the mean height of the trees in forest region A? It would be the peak over here, which is 22 meters. When it comes to region B, what is the median or mean? It would be over here, which is less than 20 meters, slightly less than 20 meters as such. So which one has taller trees? Does forest region A have taller trees or forest region B have taller trees? On the y-axis, we have essentially the distribution pattern. So that is the probability distribution as such. So basically in this case, 22 height, there is like over 30% of them are at 22 height. Around 21 height, you will have like say 21 or 22% of them are at this. So this is basically the percentage distribution as such, which means that what is the peak distribution, where is it occurring? The median of all of these heights is basically at 22 meters as such. So I would say the average, since this is a bell curve, mean and median would be clearly close to each other, especially it's a normal distribution like this. So forest region A, the average height is 22 meters. Forest region B, the average height is less than 20 meters. So whose trees are taller? The forest region A has taller trees than the forest region B. As evident from lower or higher mean. So which one has the higher mean, region A or region B? Region A has the higher mean. So since it has the higher mean, that would mean that the region A has taller trees than the region B. So because it has a higher mean, the higher mean is around 22, here it is less than 20. So because it has a higher mean, it has taller trees. So to complete the sentence properly, we should say that forest region A generally has taller trees than forest region B because it has a higher mean than forest region B. Consider the second statement. Forest region B exhibits options less, somewhat similar, more variability in tree heights compared to forest region A. So what is variability? Variability is essentially variance or Standard deviation. So how much is the standard deviation? If a distribution is narrow like this, it has low standard deviation, it has low variance, low variability. If it is fatter and flatter, it has high variability. Between these two, who is thinner and taller and less, more constrained around the mean, which is less flat? A is fatter around its tails, it is more spread out. B is more thinner, more concentrated around the mean. So which will have lesser variability? B will have lesser variability. So B exhibits less variability in tree heights compared to forest region A, as compared to, as inferred from the broader or narrower spread. The narrower the spread, the lesser the variability. So from its narrower spread, we can say that B has lesser variability than the height variability that is seen in forest region A. So from the graph itself, we can read that and answer the questions. This is the max that can be asked. Beyond this will not be asked. So you need not actually study more in detail of normal distributions. This is at max what can be asked, and this is basically how you should read them. What the mean is there? Is it broader and taller, or is it fatter and squat as such? Just that needs to be understood. If you can understand that, you can answer this is like the max that can possibly come. Okay, so this is basically how you answer questions on graphical interpretation in GMAT. We have covered distributions, and the last part, which is basically diagrams, qualitative diagrams, we'll be covering in the next part. So see you then.